Here we have section 1.3 dealing with distance and midpoints. Last section we dealt with the length of segments. Really, distance is going to be a lot like that. You're just going to look for the distance between the two endpoints on the segment, which was the same thing as finding the length of the segment. But getting into it here, I have a couple of examples to start off here. The first one I want to find, notice the length of segment AB. That's what the blue is saying there. Now, a lot of you are just going to come up here and you're going to go, well, I'm just going to count. I'm going to start here at A, kind of where it starts. I'm going to go, well, there's 1, 2, 3, 4, 5, and 6. And yeah, you're going to find out that, yeah, the length of segment AB definitely equals 6. Not a problem. Great idea. Find something easy that works. The only problem is, now what happens when we run into this? I can't really count because I didn't put all the little tick marks on there to go from -7 to 14. So we have to have a different strategy. I'm going to come back up here now. Is there some other way for us to figure out the length of segment AB? One thing would be, well, notice A starts at 1 and B ends at 7. So if I want to find the length, it's really looking at, well, how far is it in between 1 and 7? The distance in between it. Another way to come up with my 6, I could have done 7 minus 1. It equals 6. Some of you are thinking, well, what happens if I get confused and I switch them around and I do 1 minus 7? Well, 1 minus 7 is going to equal -6. Kind of the way to take care of that is we're going to put the little absolute value signs on there, because length or distance is never going to be negative. And then I can get the 6. Or you just think, well, if I'm subtracting and I want to get a positive answer, I'm going to have to do big number minus little number. So 7 minus 1. But the way to get around it, throw the absolute value on it when dealing with distance and you'll have it. Which brings us down here. How can I find the distance between them? Well, again, if we just subtract those two numbers, 14 minus -7, if you have subtract a negative, that's the same thing as adding. Some of you like to make your marks, or call it boom boom that I've heard of. And we find out that the length of segment CD is 21 units. And again, if you flip it around, you'd have -7 minus 14. That comes out to be -21, but the absolute value of it brings you right back to a positive 21. What happens when you go to the coordinate grid and I want to find the distance between 2 points? Or, another way to say it is, I want to find the length of segment EF. Well, in this one, I'm going to give you the hint right away. Good old distance formula. It's one that you're going to want to implant into your brain. We're going to use it a lot. We're using it today. We're going to use it in the future. I know you used it back in intermediate algebra or algebra 1. You're going to use it again when you get into advanced algebra or algebra 2. And it's probably going to show up even after that into maybe pre-calc and calculus. It's one of those formulas that, hey, here it is. Somehow let's figure out how to remember it, and we can go from there. And I can help you later on of showing you where this formula actually comes from. But for today, let's take our numbers and plug them in. Now notice it has these x2s and x1s and y2s and y1s. All that's saying is we have two different points. Maybe this one's point 2F. So this is my x2 and this is my y2. Well, then I have my other point, call it point 1, then this would be x1 and y1. So now it's just a matter of taking our numbers, putting them into this formula, and we'll have it. So x2, well, that's 5. x1 is 2. I have to subtract that stuff. Then I have to square it. Then I have to add on. Well, again, y2 this time is 8. And y1 is 4. If I go through now, subtract the 8 and the 4, square it, and then when everything's all said and done, I have to take the square root of it. So now I like to think of it, we just have to simplify the mess that we have up there. Make it look pretty. 5 minus 2 gives me the 3. I got to square it. 8 minus 4 is 4. I have to square that. Take the square root of it. Well, 3 squared is 9. 4 squared is 16. Add those together, I get 25. I still have to take the square root of that. End up with 5 units. That would be the length of segment EF, or the distance between point E and point F. Now the other part of this section is going to deal with midpoint. What's the midpoint? And hopefully it kind of gives itself away. Mid, start thinking middle. Point, point. We've talked about that before. So I'm going to get rid of little x and show it to you. So it's going to be that point that's halfway between the endpoints. It's in the middle of the segment. Notice what I have going on here. I have my little tick marks. Tick mark here, tick mark here, which tells me that the distance from x to m and the distance from m to y is going to be equal because those two segments are congruent. So I know, even without my definition up on top, when I look at m and these little tick marks, I know that m is right in the middle of the segment, or I know that it's the midpoint. Now, let's go back to our original problem of segment AB, where A started at 1 and B started at 7. My midpoint, it's going to be here somewhere. My question is, what's the coordinate that's going to coincide with point M? Now, some of us would think back, and there's a couple different ways to do this problem. You think back, well, we've already figured out that the length of segment AB was 6 units. So some of you are going to say, well, let's take that 6 and let's cut it in half. So 6 divided by 2 is 3. Does that mean that m is at 3? Well, that doesn't really make sense, because then from 1 to 3 is 2, but from 3 to 7 is 4. No. This 3 that we got from here, that's the length of segment AM. It's also the length of segment MB. So now what we can do is, well, if we start at 1 and we have to add 3 because we're going to the right, well, we're going to end up at 4. Another way to look at it is, well, if I start at 7 and I want to get back to M, the midpoint, well, now I'd have to subtract the length of segment MB, which is 3, and 7 minus 3 gets me to 4. Therefore, the coordinate at M is going to be 4. Now, another way to do it, that I'm going to hold off on that, would be, I like to think of the word midpoint and average. They kind of go hand in hand. It's like midpoint, it's the point in the middle of a segment. You think average, well, it's the number that's in the middle of two other numbers. So really what I can do, or another way I can do this problem, is I can take my two endpoints of 1 and 7, and I can find the average of them, which is going to mean I'm going to have to add them together and divide by how many there are. So 1 plus 7 is 8, divided by 2, and I end up with 4. Two different ways to do the same problem. And I don't care which way you do it, you pick. That was when it was on the number line. What happens when we come back here and we're on the coordinate grid? Again, this is where I go back to my whole midpoint, average. Those are two words that they're right next to each other in my brain, and I hope they are there, that you can put them right next to each other in your brain, because what you can do is you can think average, but you have to think twice. I'm going to have to find the average of my x's, and I'm going to have to find the average of my y's. So if I start with my x's, take 5, add on the 2, and then to find the average, divide it by 2. When I do that, I'm going to have 7 over 2. Some people just leave it as that because it's a simplified fraction. Others of you like decimals, turn it into 3.5, or you turn it to 3.5. There's going to be your x value at your midpoint. Now if I go to my y's, now I have 8 and 4. Divide that by 2, and that's going to put me at 12 over 2, which would be 6. Well, there's my coordinate. X value is 3.5, y value is 6. I just found the midpoint of segment EF. Now what happens when you go the other way? Now I have point E, I have the midpoint of segment EF, and I want to know, well, where is point F? And again, you'd have a couple different ways to look at it. I guess the way I like to look at it would be, well, I can figure out how long is segment EM simply by taking my 15 minus 8. So I just found out that the length of segment EM is 7. Well, that means that the length of segment MF has to be 7 as well. And then, if I'm at the midpoint, which is at 15, and now this is basically telling me that I'm going to the right 7 units. So if I add on 7, actually I like to keep this color coordinated sometimes. add on that 7, well, I'm going to end up at 22. So the coordinate at F must be 22. And again, with math, a lot of times you can check your work, and this is one of those great places. So if I have an endpoint at 8 and an endpoint at 22, is 15 really the midpoint? I take 8 plus 22, I get 30. 30 divided by 2, 15. Checks out, and I have it. What happens when you go to the coordinate grid? Again, I did a bad job of marking this one. In this one, what I really wanted to have happen is E I wanted to be the midpoint, so I should have put my tick marks on each side of point E. Now we can go through and we can find the coordinates at G. Now with this, I like to basically take this segment that's diagonal and I'm going to kind of squish it two different ways. One time I'm going to take, for this case, I'm going to take and I'm going to smoosh it down here. So I'm going to take F and I'm going to bring it down to here. And then what I'm going to do is I'm going to try to figure out, well, what's the midpoint of my blue segment? So it's going to end up right here, give or take. Doesn't look good, but it's going to work. Now, what I do know is I have a coordinate for this F that I dropped down. Being I'm not worrying about the up or down, this is at 6. Bring my E point down, which is kind of the blue one here in the middle, the midpoint. That's 2. And I'm looking for this one. And this is where I'm going to do my, well, 6 minus 2. That's 4. So this length is 4, which means the length from here to G is going to be 4. That's where I'm going to say, well, if I start at 2, now I'm going to the left 4, so I'm going to have to subtract that 4. I end up at negative 2. So I'm saying that this x value at G must be at negative 2. Now do the same thing when dealing with the y value. But now this time I'm got to go vertical. So basically what I've done now is I'm going to take G and move it all the way to the right to this blue point. Now in this case, let me take this 6 and get rid of it because I don't need that anymore because that's the x value. Now being I'm dealing with the orange, that's dealing with up and down, so all I really care about now is the y values. Well, I don't know the y value out here. That's a big question mark. But I do know the y value up here. It's 9. And I'm really looking for what's this y value about here that would be the midpoint. Well, actually, I know that. I'm sorry. We know that's 3 because that would be the y value from E. So that's here. And now this time I'm going, well, the 9 minus 3 puts me at 6. So the distance from F down to this point here is 6. Well, then the distance from 3 down has to be 6. And now I can take, I'll slide this down a little bit. I'm going to do the 3, and I'm going to subtract this 6, which is going to put me at negative 3. So that's where this would be at for a y value at negative 3, which is the same as the y value at G. So according to what I came up with, point G should be at negative 2, negative 3. And again, you could check that work. Take your x values, add them together now at F and G, divide by 2. Take your y values at F and G, add them together, divide by 2. And it'll come up to be 2, 3. The last thing I have here is a segment bisector. And a segment bisector is anything that's going to cut a segment into the two congruent pieces. I drew a picture here that's dealing with segment AB as the segment. And then you have all these different things that are bisecting it. Point M is bisecting it. You can say this line, line RM is bisecting it. Segment XD is bisecting it. Even, it's hard to see the plane, but what they're trying to show with that plane is that the plane is also bisecting the segment. The big thing out of a segment bisector, just remember something that cuts a segment in half or into two congruent pieces. And then that's going to do it for our lesson on distance and midpoints.